Welcome. In previous lecture, we talked about pressure, force multiplier, and pressure drop. We understood how a small force applied on a small area can be magnified and multiplied to hold a bigger load in an enclosed vessel. We have also discussed how restrictions or orifices will impact the pressure and create a pressure drop between the upstream and downstream of that restriction. Now we will discuss the flow characteristic of a hydraulic fluid in lecture number 4. So, flow can be defined as the action or fact of moving along in a steady and continuous stream. Both hydraulic and pneumatic systems are both concerned with the flow of the fluid, whether it is liquid or gas. And in simple, the flow is a loose term which generally can be described in three meanings. We have a volumetric flow, mass flow, and velocity of flow. Volumetric flow is used to measure the volume of fluid passing a point per unit of time, and it is dependent on pressure and temperature. When we talk about the process control, volumetric flow is the most common measurement. For mass flow, it measures the mass of fluid passing the point in a unit time. For velocity of flow measures the linear speed in meter per second past the point of measurement. Flow velocity is of prime importance in the design of hydraulic and pneumatic systems. Generally, the law for how to calculate the flow rate expressed as Q, which is equal area multiplied the velocity. When we talk about flow, we need to emphasize on two important parameters. Number one, the viscosity, and the second one will be the flow state. For the viscosity, at molecular level, viscosity is the result of interaction between different molecules in a fluid. This can also be understood that the friction between these molecules in the fluid is just a case or producing a friction. Like, for example, moving solids. You can see easily the friction between moving solids. So viscosity will determine the energy required to make a fluid to flow. For the flow state, it describes the state of fluid while transition from one point to another point. Let's define viscosity in more details. Viscosity is a measure of frictional forces between the layer of fluid producing resistance to flow. Let's imagine a fluid passing through a tube. So in the left sketch, it shows a high viscosity fluid having more friction forces between molecules of that fluid, and hence low velocity. On the right hand sketch, a fluid with low viscosity and low friction force will have high velocity and will move faster. So the velocity increases rapidly from the wall inward for a low viscosity fluid, but more gradually for a high viscosity fluid. So we can have, in brief, high viscosity fluids always flow slowly. On the other hand, when we talk about flow state, the state of flow will have two types. The first one is laminar flow state, where the flow in hydraulic system will be as a smooth transition from one point to another. All particles of that fluid will be moving parallel to each others, and there would be no turmoil or disturbance within the flow. They are just moving parallelly. The other type of flow state is the turbulent flow, and in fact, hydraulic system flow often experience more turmoils or disturbance than desirable. Although fluid generally moves in direction which is required, It also travels through small conduits, cross-shaped restrictions, and through small orifices, and hence with the tendency to cause anything but nice and smooth transition. But particles of the fluid are traveling helter-skelter among each other, causing frictions and inefficient movement. This type of flow is normally undesirable and wasteful, but unfortunately, the economic and practical aspects of mobile fluid power result in most flow being turbulent variety. We cannot avoid it, we have to deal with it, and we have to check our system design to include this one in our aspects. Another important topic we need to talk additional to the flow is the work or energy and power. Work is done or energy is transferred when an object is moved against a force. I have a force pushing the item, so here I can assume that the work is done. And work will be equal to force multiplied by the distance moved. The power, on the other hand, is the rate at which the work is performed. So the power will be work divided by time. So just keep these two terminologies in your mind. If you recall in previous lectures, we told that speed is determined by flow. And if you recall the previous example, we told when a force of 40 kilonewton applied on a piston of 2 centimeter square area can hold a load of 1000 kilonewton on a 50 centimeter square area. Now, how can we lift or make a movement of this 1000 kilonewton to a certain distance? Exactly, we need to calculate the speed or displacement of those pistons. In the law of physics, the law of conservation of energy is a principle of physics which states that in an enclosed system, energy cannot be created or destroyed. Energy must be conserved. To illustrate this, if the smaller piston on the right hand side moved by 100 centimeters inside the container, then the volume displaced from the right side to left side can be calculated as volume equal piston area by displacement. And the piston area 1 is 2 centimeter square by 100 centimeter displacement result in a volume of 200 centimeter cubic. Because we have assumed the fluid is incompressible, a volume of liquid 200 centimeter cube will transfer from the left hand cylinder to the right hand cylinder, causing a load to rise by just 4 centimeters. The same if we apply the rule here, the displacement for the second piston will be equal the volume divided by the piston area, which is 4 centimeters. It will move up 4 centimeters. So, although we have a force magnification of 250, we have a movement reduction of the same factor. Because work is given by the product of force and the distance moved, the force is magnified and the distance moved reduced by the same factor, giving conservation of energy. To summarize this lecture, let's talk about some summary of key hydraulic principle. Hydraulic or work done is a combination of pressure and flow over the time. Energy cannot be created or destroyed. Energy rather it will be conserved. Force is determined by pressure. Speed is determined by flow. Pressure without flow results in no action, and decrease in flow will increase the pressure. Flow without pressure results in no action, and increase in flow will decrease the pressure, and hydraulic pressure is the result of resistance to flow and in force. Thank you for your time. We reached the end of this lecture and see you next lecture.